So with the chain rule, let's say if you have some function y equals g of x, or even if you decided to make it u equals, or y equals g of u. So, we got a eraser. Better yet, let's make this y equals f of x. Make it a little bit easier instead of bouncing around with the definition. Okay. So like y equals some f of u, where u is equal to your g of x. And it is a differentiable function. And let's say g of x is also a differentiable function. Then if you have the composite of the two, y equals f of g of x, is differentiable. And the derivative of y with respect to x is going to equal derivative of y with respect to u times the derivative of u with respect to x. Okay. Now this is not the most used form of it. We'll use this more in implicit differentiation. We'll use more in implicit differentiation. And we'll cover that, I think, next class or the class after. I have to double check. Well, you can also rewrite this. Let's say if your, let's say y prime is equal to f prime of g of x, that's assuming that one, times g prime of x. Okay. And that's the most popular chain rule definition.
What do you mean by implicit differentiation?
Well, implicit differentiation is if you can't solve for y, but you want to find the derivative with respect to y. So with these, you can actually solve for y. All right. So like with most of these, we have to prove it. Well, we don't have to, but that's the fun. So anyone's still writing? Oh, I'll leave that up for a few seconds.
Is that y prime equals f prime times g of x plugged into f prime times?
Yep, times.
Okay.
So that's,
I thought that might have been another prime. I was like, where we at?
nope, that was just multiplication.
Okay.
Mm-hmm. Okay, so really you're just going to differentiate what's on the outside times the derivative of what's on the inside. All right, so let's do a proof of that one. So the proof of the chain rule. So keep an eye on that there. Okay. So normally we'd have the limit of f of x plus h minus f of x all over x plus h minus x, as you can say, as h approaches 0. but in reality it's as x plus h approaches x, which is still as h approaches 0. So as those get closer and closer together, your h gets smaller and smaller and smaller. But instead of that, we're going to use x and c. So this would be x, this would be c, and that would be as x approaches c. Just to kind of limit our confusion a little. F of x minus f of c all over x minus c as x approaches c. Okay, so this would be our x plus h. That would be our x, and we go from there. So we know that our derivative with respect to x of f of g of x. Okay. Oh, yep, forgot a bracket. There we go. That's going to equal the limit of f of g of x minus f of g of c all over g of x minus x minus c. Sorry about that. As x approaches c. Okay. So now we're going to multiply this by g of x minus g of c over g of x minus g of c. Just our way of kind of manipulating the equation a little bit. Okay, so that's going to give us the limit of f of g of x minus f of g of c all over x minus c as x approaches c times g of x minus g of c over g of x minus g of c. So basically we just multiply it by 1. Okay, so since this is multiplication and it is commutative, we're actually just going to switch those two. So the limit as x approaches c of f of g of x minus f of g of c all over g of x minus g of c times g of x minus g of c all over x minus c. Okay, so that's the limit of that entire thing. Okay, so just from our property of limits, we know we can distribute that to both factors. So that would equal the limit as x approaches c of f of g of x minus f of g of c all over g of x minus g of c times the limit of g of x minus g of c all over x minus c as x approaches c. Okay, so we can see here that that's the actual definition. If you remember up here, this is the definition of f prime of c. So this is the actual definition of, oh, did I mess that up? Nope, I didn't. F prime of g of c. Okay, so if you kind of look at this like if this was, let's say, a u and this is some c and u minus c, that would be f prime of c. But in this case, your internal is a g function, so that's when we're going to have that f prime of g of c times, and this is actually just your definition of g prime of c. Okay, so this actually just equals f prime of g of c times g prime of c, which is your h prime of c. which is just the derivative at some point c. If you don't have a c value picked out, then it's just f prime of g of x times g prime of x. All right, so any questions on that one? All right. Leave that up for a few more seconds. All right. Okay, so let's say, for example, we want to find the derivative of f of x. Oh, actually, let me use h of x, avoid confusion. H of x is equal to 3x minus 2x squared squared. Oops, sorry about that. All right. So for this one, you just want to remember, of course, your product rule. Power rule, sorry about that. Product rule actually comes in later examples. Okay, which is the derivative of x to the n equals n x to the n minus 1. Okay, so what we're going to do, we're going to apply the product rule to this entire thing. So that's our f prime of g of x. So h prime of x is going to equal, we're going to bring that 2 down to the front, 3x minus 2x squared minus 1. And then we're going to multiply it by the derivative of what's inside. All right, so that's going to equal 2 times 3x minus 2x squared to the first power times the derivative of 3, well, 3x is just 3, and the derivative of negative 2x squared, we're going to bring down our 2, so you have minus 4x. Okay, so this would be your answer there. All right, any questions on that one? All right. Now, if we were to do that same one using the implicit formula here, y with respect to u times derivative of u with respect to x. Okay, so let's say if we had y equals 3x minus 2x squared. Squared. Okay. So in this case, we'd let u equal 3x minus 2x squared, which means our derivative of u with respect to x is actually the derivative of 3x, which is just 3, minus derivative of negative 2x squared. We bring down our 2, we have our minus 4x. Okay, so if we start from here, just knowing our u and our du dx, our derivative of y with respect to x is equal to our derivative of y with respect to u. So in this case, once we made this equal u, forgot to get a little middle section there, this made y equal u squared. Okay, so derivative of y with respect to x is derivative of y with respect to u. So derivative of y with respect to u is just 2u to the first. Times derivative of u with respect to x is just 3 minus 4x. Okay. So if we go ahead and substitute our u back to 3x minus 2x squared, 2 times 3x minus 2x squared times 3 minus 4x. Okay. You see why this isn't used that often, because it's a little more cumbersome. But it's the same general idea. All right. Any questions on that one? All right. Okay. Okay, so let's say, for example, want to find h prime of x for h of x equals x squared plus 1 to the third power. Okay, so the first thing you want to do is you just want to apply the power rule here. So we're going to bring the 3 down. So h prime of x is going to equal 3 times x squared plus 1. Then we're going to subtract 1 times the derivative of what's inside. All right, so this is going to equal 3 times x squared plus 1 squared times the derivative of x squared plus 1. X squared, that derivative is just 2x. And derivative of a constant is just 0, so that just remains like that. Okay, so once we go ahead and just combine those two, our h prime of x is equal to 6x times x squared plus 1 squared. All right, any questions on that one? Okay. Okay, so what if we if we want to find h prime of x for h of x equals 3x squared minus 2x plus 3 to the 6th power. Okay, so our h prime of x, just using the power rule, we're going to bring that 6 down to the front. 3x squared minus 2x plus 3, and subtract 1, times the derivative of what's inside. Oops. Okay, so we end up with 6 times 3x squared minus 2x plus 3 to the 5th power times derivative of 3x squared, bring down our 2, that gives us 6x. Derivative of negative 2x is just minus 2. Derivative of a constant is 0, so that just disappears. So you just end up with that as your answer. You can get rid of the dot if you want to. 3x squared minus 2x plus 3 to the 5th 6x minus 2.
If you put that down as like 12x, or sorry, 36x minus 12, would that be okay? Like
36x minus
Yeah,
12.
36x minus 12 times.
Oh, okay, I see what you're saying. Oh, yeah, if you wanted to distribute that, you could. Yeah.
Sorry, I should have said that on the way out.
Oh, no problem.
Wouldn't you have to
Or if you,
distribute the exponent first before you go and try and boil it if you felt you needed to?
oh, if you wanted to solve this one, yeah, you'd have to multiply that to itself 5 times, and that's a whole lot of work.
Yeah.
Yep, you don't have to do that. Okay. Or if you wanted to, you could factor a 2 out of there and have that as 12 times that times x minus 1, and so many different ways to write it. All right, so if we have the example, so if you want to find h prime of x for, let's say, negative 2x squared, oh, h of x. H of x equals negative 2x squared minus 2x plus 3 to the 5th power. All right, and I'll give you a few minutes to start on that one. All right, so for this one, our h prime of x, we're going to get that exponent and just bring it down to the front. Negative 2x squared minus 2x plus 3. Then we're going to subtract 1. Okay. Then we're going to multiply that by the derivative of what's inside. Uh-oh. That looks a little odd. There we go. Okay, so that's just going to equal 5 times negative 2x squared minus 2x plus 3 to the 4th power times derivative of negative 2x squared. We bring down our 2. You have negative 4x. Derivative of negative 2x is just minus 2. Which is your final answer. All right. If you wanted to, you could factor a negative 1 out of both of those, but you don't have to. All right. Any questions on this one? Nope, actually you can factor out -2 if you wanted to, but you don't have to. All right. So let's say if you have, oh, you want to still write in? No, okay. Let's say if you have find h prime of x for h of x is equal to the cube root of x squared minus 1 squared. Okay, so whenever you have one like this, the first thing you want to do is rewrite it. Okay, so to do that, you just want to remember that the cube root of x is equal to x to the 1/3. So that means the cube root of x squared minus 1, that looks like a plus still, squared minus 1 squared, you're going to rewrite that as x squared minus 1 squared raised to the 1/3 power, which once you multiply those two, just becomes x squared minus 1 to the 2/3 power. Okay, so a little bit of that property of exponents coming back. All right, so that gives us h of x equals x squared minus 1 to the 2/3 power. No, it's positive. It would be negative if it was 1 over that. Then it would have been negative.
Well, it'd be.
You subtract 1 from 1/3 to get negative.
Didn't do the derivative yet.
Oh, no, I didn't do that yet.
It's just h of
Yeah, that's just, I'll just rewrote it.
Oh, there's a 2 inside.
Yeah.
Okay, I didn't notice that.
Oh, yeah, I just rewrote this as that. But yet, when you subtract the 1, it will be negative. Okay, so your h prime of x, you're going to bring your 2/3 down. X squared minus 1 to the 2/3 minus 1 times the derivative of what's inside. Okay, so that gives us 2/3 times x squared minus 1. 2/3 minus 1, remember that's just 2/3 minus 3/3, which is negative 1/3, times the derivative of x squared is 2x, and derivative of negative 1, well, that's just 0, so that stays there. So after we combine those two, it's going to equal 4x over 3, or 4 over 3x, whichever way you want to write it. Times x squared minus 1 to the negative 1/3, or you can make it equal 4x over 3, take cube root of x squared minus 1. All right. Yes.
If we have a question like this in the test, do you want us to rewrite it so there's not a negative exponent?
Oh, if you wrote it like this on the test, that would be just fine.